So primary winding of the transformer is connected to 230 volt 50 hertz supply. Secondary winding of transformer is connected to diode's anode terminal, and cathode terminal of a diode is connected to load resistor, and another terminal of a load is connected to secondary winding of a transformer. Here we will consider A and B points. Anode, diode's anode is this one, and here it is a cathode. We know that when diode is connected in forward bias, it is PN junction diode. PN junction diode. When diode is connected in forward bias, then it works as a on switch. And if it is connected in reverse bias, then it works as a off switch. Okay? Now understand one by one all these points. So here we'll see working of rectifier, half wave rectifier. Working of half wave rectifier, it is divided into two parts, positive half cycle and negative half cycle. Positive half cycle and negative half cycle. Positive half cycle, when we gives input to this rectifier, here consider omega t, and here input voltage Vn. It starts from 0 to pi, then 2 pi and 3 pi. So here this one is the, we will consider this as the output voltage across the load resistor, omega t. So in positive half cycle means this part of a input voltage. If suppose input is applied, positive half cycle, in positive half cycle, L terminal is positive and N terminal is negative of the transformer's primary winding. Then as L is positive and N is negative, so we can write L is positive with respect to N. As L is positive with respect to N, therefore A terminal, A is positive with respect to B. A is positive, A terminal is positive with respect to B. If A is positive, that means diode D is in forward bias. So diode D is in forward bias. Forward bias. And we know that when diode is in forward bias, then it works as a on switch. So it will works as a on switch. And therefore, this diode start conducting and current flowing through the diode, that is called as I current, IL. So current flowing through the diode, and it will complete its path from A point, then diode D, then RL, and again B point. So like this current flows through the circuit. This is in positive half cycle. So we will get a waveform at the VL in positive half cycle. Consider negative half cycle. Negative half cycle. In negative half cycle, that means this part. In negative half cycle, L is negative with respect to N, and therefore L is first step, L is negative. L is live terminal, N is neutral terminal. So L is negative with respect to N. If L is negative with respect to N, therefore A is negative with respect to B. A is negative with respect to B. If A is negative with respect to B, that means anode of the diode is connected to negative terminal. That means it is in reverse bias. So diode D is in reverse bias, and when diode is in reverse bias, then it works as a off switch. As diode is in reverse bias, so it works as a off switch. Okay. As diode D is in reverse bias, it works as an off switch. So there will be open circuit. There will be like this. No connection will be there in between the load resistor and secondary winding. So no current will flow because circuit will not get completed in that case. So no current will flow through the diode. No current will flow through the circuit. No current. And VL is equal to 0. Here VL is equal to VAB. Whatever the input voltage was there, whole voltage was appear across the VL in case of positive half cycle. Whereas in case of negative half cycle, it is equal to 0. And IL is also equal to 0. This is a half wave rectifier. In next half cycle, again that is positive half cycle. In positive half cycle, again A is positive with respect to B. A is positive with respect to B. If A is positive with respect to B, then diode D is in forward bias, and when diode is in forward bias, then L is positive with respect to N. Live terminal is positive with respect to N. Therefore, A is positive with respect to B. Diode D is in forward bias, and when diode is in forward bias, then it start conducting. It works as a on switch, and whole current or the current flowing through the circuit is IL. Again IL, and voltage, whatever the voltage, that is VAB. The whole voltage will appear across the load voltage VL in positive half cycle. So again we will get a waveform in positive half cycle. In next negative half cycle, again L is negative with respect to N. Diode D is in reverse bias. It works as an off switch and no current, that is IL becomes 0 and VL is equal to 0. No current will flow through the circuit, and therefore voltage across the RL is equal to 0. This is the working of half wave rectifier. We'll see waveform of half wave rectifier and parameters. Waveforms of half wave rectifier here, omega t. Then input voltage, it starts from 0 to pi to 2 pi. That is one complete cycle. This is input voltage, and the secondary winding, it is VAB. 0 to pi, 2 pi, 3 pi and 4 pi. Then next waveform is voltage, omega t. Load voltage, load current, and for conduction of diode there is a voltage required. That voltage we will see. This one is omega t. this one is VL, and here it is IL. We had seen in positive half cycle diode is conducting. So diode conducts in positive half cycle 0 to pi. In negative half cycle diode do not conduct. So again this one is 0. Here it is 0, here diode on. Then in next half cycle again diode conducts, therefore diode D is in on state. In next half cycle diode do not conduct. So again it is equal to 0. Here current waveform will become same as voltage waveform, but the load is resistive. Therefore only smaller current waveform is same as voltage waveform, only the load is resistive type of load. So peak of this voltage waveform, it is little longer or higher as compared to the peak of this current. So this part is called as Vm, and this is called as amplitude, that is Im. Again here it is 0, 0, 0 to pi, 2 pi, 3 pi, 4 pi, and so on. Again 0 to pi, 2 pi, 3 pi, 4 pi, and so on. Clear? If we consider the average value of this, then that average value is called as VLDC or V average. If we take the average value of this, then this value is called as ILDC or I average. Clear? Now first parameter for this is considered as a ILDC. ILDC. As if we consider one cycle, one input cycle, then it starts from 0 and at 2 pi. So one input cycle and it is from 0 to 2 pi. Therefore, we will consider this as a formula for this is 0 to 2 pi integration of 0 to 2 pi IDC into d omega t. D omega t. But we know that sine waveform is there, therefore IDC's equation is 0 to 2 pi Im sine omega t. Im sine omega t into d omega t. If we solve this integration, then here 1 upon 2 pi integration of 0 to pi Im sine omega t plus integration of pi to 2 pi Im sine omega t into d omega t. But here if we observe, then this part is there and this part is become 0. In the waveform this part is become 0. Therefore this is directly 0, and here it is 1 upon 2 pi integration of Im sine omega t. Im is the constant term, so I'll take it out, and then sine omega t is minus cos omega t integration if we solve, and limits are 0 and pi. So final value is Im sine omega t. Im divided by, take minus sign outside the bracket, Im divided by 2 pi into cos of pi minus cos of 0. So these values if we calculate, then final answer become -2 and 2 get cancelled, so it becomes Im upon pi. Im upon pi. Clear? This is first parameter, that is ILDC. Then VLDC. VLDC is, we know the second parameter VLDC. VLDC is equal to ILDC into RL. By Ohm's law, V is equal to IR. V is equal to IR. So ILDC into RL. ILDC is how much? Im upon pi into RL. Here one more term, that is Im. Im is equal to, as in half wave rectifier, there are 3 resistors. That is internal resistor. 2 resistors are internal resistor. So formula for Im is Vm upon Rs plus Rf plus RL. Here Rs is secondary windings resistor, secondary winding resistor. Transformers, secondary winding resistor or resistance we can say. Then RF is forward diodes resistor, forward biased diodes, forward diodes resistor. And RL is the load resistor. Load resistance. These are the terms in case of this formula, Rs plus Rf plus RL. Third term, third parameter in case of half wave rectifier is IRMS. IRMS is nothing but the value of this RMS value. If we calculate the average of this line and take a square of this I average and take a under root square and under root of this value, then that is called as RMS value. IRMS in case of half wave rectifier, it is Im upon 2. In your syllabus, there is no detail about the IRMS, VRMS, detailed formula. It's only formula is there. VRMS is equal to Vm upon 2. Vm upon 2. Then efficiency, rectifier efficiency. In any case, efficiency is nothing but the ratio of output divided by input. Output power divided by input power. So rectifier efficiency is nothing but the DC value, ILDC value and VLDC power, output power divided by input power. Output power divided by input power. Output power is always calculated by formula I square RL. So ILDC square into RL. ILDC square into RL, and input power is RMS square into RL. This is rectifier efficiency. If we calculate the efficiency in half wave rectifier, then it is only 40%. And this efficiency is very low compared to full wave and bridge wave rectifier. So we'll see next is full wave rectifier. Okay, half wave rectifier. There are some disadvantages in half wave rectifier, that ripple factor, efficiency is very low in case of half wave rectifier. and only one half is used from the input. So from the input there are from the one input cycle, AC input cycle, there are two half cycle, positive half cycle and negative half cycle. So in half wave rectifier only positive half cycle is used, negative half cycle is waste of energy. So that energy is getting waste and therefore their efficiency is very low. Efficiency is low in case of half wave rectifier. Therefore, full wave rectifier is invented. Full wave rectifier. Consider the circuit diagram for full wave rectifier. In full wave rectifier, center tap transformer is used and two diodes are used, diode D1 and diode D2. Load resistor, RL, and here we'll show it by no connection in between the two wires. Here again center tap transformer. This is named as O. 230 volt AC supply. Again L and N, A terminal and B terminal. Diode D1 and diode D2. Load resistor. Across the load resistor voltage is VL. This is the circuit diagram for full wave rectifier. Understand the construction of full wave rectifier. In full wave rectifier, there is again transformer is used at the input side. But in case of half wave rectifier, it was a step down transformer. Here it is a center tap transformer. Center tap transformer, it works like if primary winding voltage is 12 volt, then secondary winding voltage is divided into two parts, that is 6 volt in first half and 6 volt in this part. So A to O it is 6 volt and O to B it is 6 volt. That means primary winding voltage is divided into two equal parts at the secondary winding. That is a center tap transformer. Clear? Here instead of one diode, two diodes are used, diode D1 and diode D2. Load resistor is connected across both the diodes. Here load resistor is connected, anode of the diode is connected here at A point and cathode of the diode is connected to load resistor and another terminal of a load resistor is connected to O point. Same way here anode of the diode is connected to B point and from there it is connected to load resistor and then again load resistors another terminal is connected to O point. That is the full wave rectifier. Understand the working of a full wave rectifier. Again full wave rectifier's working is divided into two parts, positive half cycle and negative half cycle. First, positive half cycle. First point of positive half cycle. Here also input of the transformer is connected to 230 volt AC supply. That means here input is positive half cycle will give positive sine wave and negative sine. like this. This is the input omega t and input voltage, that is VAP. This one is positive half cycle, that is from 0 to pi. So in positive half cycle, L is positive. L is positive with respect to N. If L is positive with respect to N, then we know that A is positive at the secondary winding. A is positive with respect to A is positive with respect to B. If A is positive and B is negative, then diode D1 is in forward bias. And diode D2 is in reverse bias. D2 is in reverse bias. We know that whenever diode is in forward bias, then it works as a on switch. So diode, it works as a on switch or close switch. And if it is in reverse bias, then it works as a off switch, or it is called as open switch. Works as a off switch, or it is called works as a open switch. Then next point is if it is in forward bias. So here this one is in reverse bias, so it will works as a open switch. And this one is in on state. So current will flow from here to here and then here. Current path for this half cycle is VA, then diode D1, then load resistor RL, and then again VO. This way current will flow through the circuit. So whatever the voltage across the secondary winding, that is VAO is equal to VL. VAO is equal to VL in positive half cycle. Now consider negative half cycle. Negative half cycle. Second part, negative half cycle. In negative half cycle, L is negative. L is negative with respect to N. So L is negative with respect to N. If L is negative with respect to N, that means A is at the secondary winding, A is negative with respect to B. That means this one is negative and this one is positive. At the secondary winding, A is negative and B is positive. If A is negative, that means O is positive. And B is positive, that means O on this side it is negative. If L is negative with respect to N, then A is negative with respect to B. And same for O, opposite for O. O is negative on the lower side and O is positive on the upper side. So diode D1 is in reverse bias. And diode D2 is in forward bias. If diode D1 is in reverse bias, that means it works as a, if it is in reverse bias, it works as a off switch. Off switch. And if it is in forward bias, then it works as a on switch. It works as a on switch. So current path for this is will be open switch and it will be closed switch. So current path will be from B diode T1, D2, then RL, and then again it will come back from this side. So current path will become VB, diode D2, then RL and VO. So in negative half cycle also we will get a waveform. So whatever the voltage here, that much voltage will appear across the RL. So VL is equal to VBO. VL is equal to VBO. So in both the half cycle, we will get the output voltage in case of full wave rectifier. In positive half cycle also and in negative half cycle also. VL. Clear? This one is 0 to pi and again here 2 pi. We'll see waveform for full wave rectifier. Full wave rectifiers waveforms are this is input waveform VAB 0 to pi to 2 pi and 3 pi and 4 pi. Then voltage across VD1, we can say VD1. VD1, here we will get a voltage, that is diode D1 is in on state. Diode D1 is in on state. Then at voltage at VD2, it is on in negative half cycle. So voltage we will get in negative half cycle also. Voltage at VD2. If we add these two voltages, then we will get the total voltage at the output, that is VL. So total voltage VL. Total voltage VL, that is in both the half cycle. In positive half cycle, in negative half cycle, that is VL. 0 to pi, 2 pi and so on. Clear? Same way we will get the current at the output, and here the load is resistive load, therefore current is peak amplitude of a current is little smaller as compared to voltage because of resistive load. So in full wave rectifier, we will get the waveform in both the half cycle, positive half cycle and negative half cycle. Here diode D1 is in on, diode D2 on, diode D1 on, diode D2 on, and so on. Clear? Okay, thank you.